Hi gents, we're going to have a quick look at the past paper question that I set you. I know a couple of people asked about this thing here, just to go over it. They were finding it a little bit tricky, so we will do that here. Apologies for being a bit late today. I wanted to get this out a bit earlier, but just anyway, we're here now. So let's have a look at it. Question 2a. I think I'll make out two videos. I'll do the A part first here. So we've got two cars, A and B, travel along straight roads which intersect at angles of 135 degrees. Car A is moving towards the intersection at a uniform speed of 60 kilometers per hour. So we will say that A is doing 60 I's and 0 J's. That bit is easy enough. And for B, okay, so with B, I'll just have a little bit of a think about this. B is doing, well, it's claiming that this is 135. We know that that's a right angle, so that's going to be 90. So this extra bit here, sorry. So if we have 90 and the whole thing that I have there is 135, we're dealing with 45 degrees there, and we're also dealing with 45 degrees there because that is a vertically opposite angle. Okay, if I were to get rid of that thing, nope, not that thing there, sorry. Pardon. This bit is 45. That's our vertically opposite part here. That's the one I should get rid of. That's 45. And we know as well that we're dealing with a right angle there. So we've got 45 and 45. Okay, with that in there, what are we going to say about B? We're going to say that since it's 45 degrees that we have inside there, I'll actually zoom in on this, it's a little bit easier to write on it, that's much better. So we had said that that was 45 along with this being 45 and that being 90. So we now know that that length is the same as that length there. Okay, what else do we have? We have what is its magnitude? We know that it's 45 as well. Now that's kilometers per hour, just to be clear, okay? So one is degrees and one is 45 kilometers per hour. We know that that's a 45 degree angle as well while we're at it. Okay. Look, there's a couple of ways to do this, but let's just say this. Since it's 45 degrees, that is the same as that. So we have an isosceles triangle. We have x and x, and we've got 45. So there's a few ways to go about it, I suppose. You can say x squared plus x squared is equal to 45 squared. So 2x squared is equal to whatever it's equal to. We'll just call it 45 squared. X squared is equal to 45 squared over 2. And x is equal to the square root of that. So actually, that's the handy part of leaving it like that, because you know that you can square the top, square root the top, I beg your pardon, and square root cancel, 45, and you can root the bottom, root 2. I imagine if you type that into your calculator, it'll say 45 root 2's over 2. But just to be clear, root 2 over 2, that on its own, this is root 2, and 2 is root 2 times root 2, so it's the same as having 1 over root 2. Okay, so if you've got 45 over root 2, this is the same as having 45 multiplied by root 2 over 2. Okay, and we can make that times 1 as well, and times that. So, two ways of writing it. I'm going to keep it to this. I think this is a nicer way to have it. Okay, that's what x is. So actually now we can say up here where we had what A was doing, we now know what B is doing. So it's going to the left by this, so that's minus 45 over root 2i. And it's going up the same amount. It's going up 45 over root 2j's. Okay. There would be other ways to do that. Let me just give you another way, because it's, been a while since I've seen you in person, so normally I would ask you this in class. And of course, what we would find is this. We would find that if this is 135, okay, going the whole way along there. I'm really struggling now to say with the pen. I gotta be a little bit careful, a little bit more careful with it. Sorry. So my question is that if that is 135, what is this thing here? Okay, and I think that you can tell that we are dealing with the exact same thing. We're dealing with 45 as we knew there and a right angle. So that is 135 itself, okay, the whole way along. So remember our h cos theta I plus h sine theta j. So in this case, h is the magnitude, so that's 45, and it would be cos of 135. Where am I getting that from? Starting from here, you have to go 135 degrees to get there, plus 45, which is again the magnitude, and it would be sine 135. So these are the I values and those are the J values. And I will just double check that I'm not talking nonsense. So if we say 45 cos 135, will it come out to be negative? It will. It'll say minus 45 root 2 over 2, which as we said is the same as saying minus 45 over root 2. So you get that, and it works for the whole thing. Okay, so what do we have? We've got what A is and we've got what B is. Okay, and that's all totally standard stuff. Nothing tricky there, hopefully. And you wouldn't have had to spend so much time doing it as well. I'm just trying to explain it, I guess, as we go along. Find the magnitude and direction of the velocity of B relative to A. Well, that's easy enough. B relative to A is B minus A. Okay, so we take our B value and we subtract off the A value. So we take minus 45 over root 2 and we subtract off 60. That's how many I's we have. And we start with 45 root 2's and we take away no J's from A. So that's what B relative to A is. Okay, nice enough. But they ask specifically for the magnitude and the direction. Okay, so what is this thing doing? What this thing is doing, we'll change colors, is it's this is now specifically B relative to A. Okay, it's moving over to the left. It's moving over it's moving over. Technically, it's moving over 45 over root 2 plus 60. Okay, it's moving over like the positive amount of, if this was minus 5 I, we'd say it's moving over 5. Okay, and since both of those are a negative number, they'll add together to give pure negative number, and then we would make it positive. So it's up to you if you want to call it positive or negative. It doesn't actually matter as regards getting the magnitude, because it's going to be squared anyway. And this part here, it's going up 45 root 2. So we're looking for the magnitude here. We can call it m, we can call it h, but it's Pythagoras' theorem, most certainly. So it's h squared is equal to, if you want to leave it as negative, feel free, minus 60. Just make sure that they're both negative, that would be important, plus 45 over root 2 squared. And so if you just bash that into your calculator, which I will do here. Okay, the calculator actually doesn't give like a root number or anything like that, so I'll just do it to 2 decimal places. 97.2 is what I'm getting out of that one. So actually, you know what, if they're going to be like that, we may as well just put in some numbers. So this number here is minus 91.82, so it's moving over 91.82, and it's moving up. This number here is 31.82, so it's going up 31.82. Okay, that's fine. And what does it ask us to do? It asks us to calculate its direction as well. So we have the magnitude. Okay, the magnitude of B relative to A is 97.2. We would write it like that. And to get the direction, it's just tan. Tan theta is the opposite, 31.82 over the adjacent, which is 91.82. So theta is equal to tan inverse all of that. And again, it's not a perfect number, but we'll just go to 2 decimal places, 19.11. So what I would say is that the direction is, what's it going? Remember, it's going in that direction, so that is west, 19.11 degrees north. Okay, there's our answer to our 2 parts. Or sorry, to the 2 questions that I asked, actually just for part 1. Okay, find the shortest distance between the cars. Now this is really important. So the first bit there you should hopefully be able to do in your sleep. The second part, not so much. The only thing you could get wrong, I think, in the first part is maybe like 135 confused you a little. Maybe you wrote down the wrong angle, or you got the signs wrong. That's, I suppose, it was a possibility, but you shouldn't. But the next bit tells you whether you have really understood this topic as I've been explaining it to you. Find the shortest distance between the cars. So let's have a little quick read of it. 2 cars traveling on straight roads. Okay, car A is moving towards the intersection at a uniform speed of 60 kilometers per hour. Okay, we've had that. Car B is moving towards the intersection at a uniform speed of 45 kilometers per hour. And it passes the intersection 2 minutes after A. Okay, so B is going to make it all the way there. Okay, B is going to make it there, but it'll be 2 minutes. He'll arrive 2 minutes after A. So A is already going to have gone through. So A is going to be here. So we'll have A there, and we will have B here. Okay, and that's the important thing. What you want to do is you want to let time develop for that to happen. Okay, so we let B make it all the way so they are in line with each other. And what it said that this was going to happen 2 minutes afterwards. So if we just have a little think about that, it's going at, what's A going at? A is going at 60 kilometers per hour. So 2 minutes. So it's 2/60ths, like 2 minutes out of 60 minutes. 2/60ths of 60. So it is going to go 2 kilometers in that 2 minutes. 2 kilometers. That is its distance from A to B at that particular moment. Okay, let's do a little diagram of that now, and we'll use the bit that we had a second ago. So what we have here is we've got, maybe I'll just do the diagram black if that's okay. We've got B here, and we've got A perfectly in line with it, and we've got 2 kilometers. Okay, and what we got was we got over here what B is doing relative to A. Okay, so from A's perspective, what is it that it is doing? Okay, is my screen gone a bit weird? No, it's just the processor. Okay, what is B doing relative to A? Okay, and this is what we know that B is doing. We know that B is going relative to A. Don't know what is happening there with the processor. It's just struggling a little bit, sorry. What it is doing is it is moving, as seen from A's perspective, it's moving over 91 for every 31. And I'll just track that back. Okay, it's moving 31.82. I have no idea what's happening. I'm really sorry about this. I don't know, it's something to do with how it renders the image. And this is 91.82. Okay, we know that that is what it is doing relative to A. So from A's perspective, this is how B is going to sail by. Okay, we know that this angle, we actually got it here, and that's why it's so important. That was 19.11 degrees, which means that this is also 19.11 degrees, y vertically opposite angles. And of course, we're looking for the shortest distance between A and B. And as I said in the video, my very lengthy explanation, which I wrote down, is that that is when we are at right angles to this thing here. And X will be our shortest distance. Okay, so that is the trick to doing this, it's to allow time to develop until A and B are perfectly in line with each other. We know that A has been traveling for 2 minutes when that happens from the point where B now is. 2 minutes is 2 kilometers worth of distance. And what you're now doing is you're just looking at what way is B moving relative to A. That is to say, if A were to remain still, what would it look like B is doing as seen from A's perspective. And what it looks like it's doing is it looks like it's moving left 91.82 and up 31.82. So drawing that in there, you can calculate the angle, and then if you just track it backwards, okay, where it did come from, you can see that actually before that moment when they're in line with each other, they were actually closer again than what 2 kilometers is. Okay, you know what this angle here is. You know that by vertically opposite angles, that's 19.11 degrees. And thankfully, the shortest distance involves the right angle. So we can now use, what's that? That's the opposite, and the hypotenuse sine. Say sine of the angle is equal to the opposite, which is x, over the hypotenuse, which is 2. So x is equal to 2 sine 19.11. So we'll just type that in. Okay, now remember this is in kilometers, yeah. 0.654. Did it say any? So you don't just find the distance. Okay, well, it's up to you. You can say that many kilometers, or you can say that the distance between them is 600 and, well, it's 6476, so 655 meters if you were doing it with meters, I guess. They didn't specify, which is a bit of a pain. You could just write the previous 1 kilometers, except I think even 7 gets rounded up. So you could say 0.655 kilometers if you wanted to. I'm not sure what I'd do in the exam. Maybe I'd write out all the decimal places and go from there. Okay, the video is a little bit longer than what you should be taking for the question, but that's because I want to really explain it out and maybe do it in several different ways for you. Just a very quick recap. Write out what A is doing, easy. Write out what B is doing. You should be able to draw a diagram. That's just the start of vectors. B relative to A, take B, subtract A. To get the magnitude, you just use Pythagoras' theorem, really, to get that. To get the angle, it's just tan. And then what do we end up doing? Yeah, so the big part is in part 2, A part 2. What you want to do is you want to let the situation develop so that B is in line with A, figure out what the distance is between B and A, and then draw in that line that we just got. Draw in what B is doing relative to A. And if you draw that in and just trace it backwards, what you will see is you end up with your 19.11 degrees inside a right angle triangle and the distance 2 kilometers, and then it's just simple. You can go and solve it. Okay, so just lots of practice with those, and what I'll do is I'll make a separate video for the B part, because otherwise it'll just be too long. Okay, gents, thanks a million. Catch you soon.